This is section 3.1, part C. And we're going to be solving systems of linear equations in 3 variables. So in unit 1, we worked with linear equations in 1 or 2 variables. Here it's going to be in 3 variables. So let's just give some examples right now of a linear equation in 1 variable. That might look something like 3x plus 4 equals 7x minus 9. Something that has 1 variable and your goal is to solve for x. Okay. An example of a linear equation in 2 variables. Our most common examples are of the form like y equals, for example, 2/3 x plus 1. It's something that you're going to recognize as linear being a line. So if it's just in 1 variable, your goal is to solve for the x value. If it's in 2 variables, you have a relationship between the x and y values, so you have something that is in 3 values. Sorry, I was thinking of the second one, 3 values. If something that's in 2 values, then the graph is going to be of a line. We're going to look at, in the next case right here in 3 variables, is going to be something that is going to have x, y, and z. So it might be something like 2x plus 4y minus z equals 8, something like that. So similar to our linear in 2 variables where we could have had x and y on the same side, in our 3 variable case, we usually do see all 3 letters x, y, and z on the same side. Each of these equations is linear because there are no exponents on any of the variables. Okay, we just have to increase the number of variables from 1 to 2 to 3. Okay, so recall that the solution to a linear equation in 2 variables is an ordered pair, x, y, on our line. The solution to a linear equation in 3 variables is an ordered triple. And the order would be x, y, z. In example 6, I want to decide whether the given ordered triple is a solution to the equation 2x plus y minus 3z equals 7. So we're going to plug each of these ordered triples in. So the first value must be the x, second value the y, third value the z. So I'm going to have 2 times x, which is 4, plus y, which is 5, minus 3 times z, which is 2. And I want to know, is this equal to 7? So first, 2 times 4, that's 8. So 8 plus 5 minus 6. Is this equal to 7? 8 plus 5 is 13. 13 minus 6 is 7. So the answer to the first one is yes. The first order pair is a solution to the equation. Let's check the other one as well. 2 times x, so 2 times 3, plus the y value, which is negative 2, minus 3 times the z value, which is negative 1. I want to know, is this equal to 7? So that would be 6 minus 2 plus 3. Is this equal to 7? And once again, 6 minus 2 is 4, plus 3 is 7. So once again, yes, the answer is true. This one is equal to 7. All right. So this brings us to the conclusion that just like our lines, where our lines have infinitely many points that make them true, our equations in 3 variables, which are planes, if you're interested, so like a plane is a sheet of paper or something like that in space, these also have infinitely many solutions. Okay. Now, example 7 is slightly different. It says the ordered pair 2, y, 5 is a solution to the equation 2x minus 3y plus z equals 9. Find the missing coordinate. So I'm going to find the y value that makes this ordered pair an actual solution. So I'm going to plug in the x value and the z value and solve for the y value. So x is 2, so I have 2x, so 2 times 2, minus 3 times y, plus z, which is 5, equals negative 9. And we're going to solve for that y value to make this ordered triple a solution. So that's 4 minus 2 times 2 is 4, so 4 minus 3y plus 5 equals negative 9. 4 plus 5 is 9, so I'm going to end up with negative 3y plus 9 equals negative 9, and then we're going to have to subtract that 9 from both sides to get the negative 3y by itself. That's going to be equal to negative 18, and I'm going to divide out that negative 3 to get my y value of positive 6. So my answer is going to be that the ordered triple 2, 6, 5 is the solution. I already knew the x and z values. I just needed to solve for the y value to make that ordered triple a solution. Okay. So we're going to flip onto the back side of this page now. And on the back side, we're first going to recall how do I use substitution or elimination to solve a system. Actually, we're going to be focusing on elimination in this section because we're going to be using that technique with my 3 variable equations. So this equation with these 2 variables is straight out of Unit 1. We've already solved by elimination method in Unit 1. And remember that what I would do first is look at the x's, try to find the common multiple. So you're looking at 3 and 5. And I would have to use a 15 for the x's, and for the y's, 3 and 6. So I would just be able to use a 6. So since that is smaller, we're going to go for getting rid of the y's first. Okay. So what I would do then is multiply both equations by whatever it was going to take to create a 6 and a negative 6 in one of the equations. Since I already have a 6 in the bottom equation, we're just going to multiply that one by 1, so no change. And then the top equation then would need to become a negative 6. You have 1 negative 6, 1 positive 6. So I'm going to have to multiply the top equation by negative 2. Okay. So that gives us negative 2 times negative 5 is 10x minus 6y equals negative 9. Bottom equation just times 1, so no change. So 3x plus 6y equals 21. Remember, our goal here is to add these 2 equations together to eliminate a variable. In this case, we're eliminating y. Okay, so I apologize for the cut in the video, but I just noticed a mistake that I had to correct here. I was multiplying by negative 2, and I accidentally forgot to change the sign on this 9 right here. So let's change this real fast, and let's just walk through what I've just done. So negative 2 times negative 5 is positive 10x. Negative 2 times 3 is negative 6y. Negative 2 times negative 9 is positive 18. That's my correction. And then I just multiplied the bottom equation by 1, so it's still 3x plus 6y equals 21. Now we're going to add the 2 equations together. That's what we do in the elimination method. We add them together to eliminate the variable because in this case, negative 6y plus 6y is 0. The x's add up to 13x. And then on this side, I've scribbled out my mistake right here. I've got 18 plus 21, which is going to add up to 39, and then I'm going to divide both sides by my 13 to solve for x. Hopefully that made sense. I'm sorry, I accidentally forgot to change the sign on my 18 a moment ago, and so I had a mistake right there. So my x value comes out to be 39 divided by 13, which is 3. Once you found your first value, your x value, you're going to take that value and plug it in to either of the equation, didn't matter which. So I'll just go ahead and use this second equation because the coefficients are smaller. We're going to say 3 times the x value is 3 plus 6y equals 21. And that gives us 9 plus 6y equals 21. And then we subtract 9 from both sides. We're trying to find the y value now. So it gives us 6y equals 21 minus 9 is 12. Then I divide both sides, by 6. That's a funny looking 6 there. And that gives me a y value of 2. Okay. Answer an ordered pair for these guys. So my answer would have been 3, 2. All right. So we're using this example from Unit 1 to kind of give us a reminder, first of all, of how the elimination method works. And what we're going to be doing now in Unit 3 here to eliminate equations in 3 variables is to, well, if there are 2 variables, there will be 2 equations. If there are 3 variables, there are going to be 3 equations. So what I want to do first is take a pair of equations, just 2 equations, and get rid of a variable. Then take any other pair of equations and eliminate the same variable. Very important that I eliminate the same variable as I did in step 1. That's going to give me 2 equations now that have 1 variable eliminated. So I'm going to have a system in 2 variables that I can then solve using either substitution or elimination. Once I finish solving for the first variable, plug it into one of the 2 variable equations, get the next variable. Once I have 2 variables, plug it in, get my third variable. So let's take a look at how this works on the next page. Okay. When I look at example 8, I see that I have 3 equations and 3 variables. And so I want to decide which pair of equations that I want to eliminate a variable first in. So I'm going to eliminate either x, y, or z in 2 pairs of equations. I'm just kind of considering which coefficients are smaller. And I notice that I've got 2x, 3, so 2, 1, 3, 3, 5, 1, 1, 5, 3. So I'm really just going to pick the x's to go first just because they happen to have the smallest coefficients. Okay. So I've kind of already picked out these 2 equations to work with. So I'm just going to begin with working with the 2x and the x, trying to eliminate. So the very first thing that I'm going to do is multiply the second equation by negative 2, because then I'll have a positive 2 and a negative 2, and I'll be able to eliminate x. Okay. So that gives me the top equation with no change, 2x minus 3y plus z equals 2. Then we're going to have our negative 2 distributed through. So it's going to be negative 2x plus 10y minus 10z equals negative 6. When you add these two equations up, the x value will eliminate. It's going to give you negative 3 plus 10 is 7y. 1 minus 10 is 9z. And 2 minus 6 is negative 4. So we've got an equation now that does not have x, only has y and z. Okay. Now, we're going to do this again with two other equations. I can either choose first and last or second and last to get rid of the same variable. It's very important that I get rid of the same variable 2 times. So I must get rid of x again. Okay. So since the coefficient in the middle one is smallest, it makes the most sense for me to eliminate the x again with equation 2 and 3. This time I need to multiply by negative 3 so that I'll have a positive 3 and a negative 3 to eliminate that x variable. Okay. So my next set is going to have negative 3x, negative negative, so positive 15y, negative 15z equals negative 9, and then you're going to have no change for your bottom equation, 3x plus y minus 3z equals 15. Okay? Add those equations together. Let's see. Oh, equals 5. Goodness, I'm making so many mistakes today. Hopefully I don't need to redo this part again. For some reason, I accidentally did 3 and 15, but that's the one where I do no change, right? I apologize for that. All right, so now let's add up our x's. Once again, those eliminate, just as they did before. This 15 plus this 1 is going to be 16y. This negative 15 minus this 3 is going to be negative 18z. And a negative 9 and a positive 5 are going to add to negative 4. Okay, so this gives me now two equations that have only the variables y and z that I'm going to be able to use to eliminate the one variable. So looking at the numbers 7 and 16, there's not a whole lot in common there, but 9 and 18 work very well together. So it makes the most sense for me to eliminate z here. And I'll be able to eliminate z if I multiply, 18 is the common factor, right? So if I want to leave this one as a negative 18, I can multiply the top equation by negative 2, bottom equation, just keep it by 1, and I'll be able to have a positive 18 to go with my negative 18. Okay, so I'm going to have, let's see, negative 14 for my negative 2 times my 7, y. Negative and a negative are going to make that positive 18z, and negative and a negative, so positive 8 on the other side. This one just no change, 16y minus 18z equals negative 4. The z's this time eliminate. That gives me negative 14 plus 16 is 2y equals 8 minus 4 is 4. And I'm finally going to have, if I divide by 2, goodness. If I divide by 2, I'm finally going to have my first value. My y value is 2. Okay? Now, what do you do with that y value? You're going to take it and plug it back into one of these two equations that only had the variables y and z to find the z value. Once you have two values, you go back into your original to find the third. Okay, so since y is 2, I like the top equation better because it just has a little bit smaller numbers. So we'll go ahead and use that one. I'm going to do my work over here. 7 times the y value is 2 minus 9 times the z value equals negative 4. So it's going to be 14 minus 9z equals negative 4. Subtract 14 from both sides. Negative 9z equals negative 18. So if you divide both sides by negative 9, your z value turns out to also be 2. Okay? So far I know two different values. I know the y value and the z value, so I need to use an original equation. I can choose which one to find the x value. Makes sense to me to choose the middle equation just because the x coefficient is 1. So we're going to write down x minus 5y, which is 2, plus 5z, which we've already also found is 2, equals 3. So this gives me x minus 10 plus 10 equals 3. So in this case, since those add to 0, I just get x is 3. Phew, finally found all 3 of our values. So my solution is going to be the ordered triple, 3 for x, comma 2 for y, comma 2 for z. All right. There's my answer, my ordered triple. Okay, let's see if we can get to the next one without having to cut for mistakes. All right. So in the next one, once again, 3 equations, 3 variables. Now this time, I don't have each variable in each equation. So the first equation is missing the z, the second equation is missing the x, the third equation is missing the y. This is actually good for me because it means that I already have equations in 2 variables. So what I would like to do is take, for example, the first 2 equations and eliminate y, because if I can eliminate y and have an equation that only has x and z, I'll be able to work it with a third equation. Okay? These 2 equations I chose because they are particularly suited to eliminating y, because you already have a positive y and a negative y. So I'm going to take and just kind of space them out a little bit, but 2x minus y, space for the no z, equals negative 8. Underneath y, line up your y's, right? And then plus, here's your blank space for your 3z, equals your 22. They're already set up to add the 2 equations and eliminate the y value. That's going to give me 2x plus 3z. The y's eliminate, add your x's to nothing, add your z's to nothing, equals, and negative 8 plus 22 is 14. Okay, now the 2 equations that we're going to use that only have x and z are the original third equation and our new equation here. So what I would probably want to do is eliminate maybe x, just because the coefficient is a little smaller, 2 instead of 3, but they're basically the same. So this one already has a 2, so I would need to multiply this equation by negative 2 to have them match up. So negative 2 times x is negative 2x. Negative 2 times negative z would be positive 2z. And negative 2 and negative 8 would be a positive 16. Then this equation would have no change. It already had a positive 2, so we'll leave it as positive 2x plus 3z equals 14. The x's are going to add to 0 here. I'm going to add up to 5z, and we're going to add up to 30 when you do 16 plus 14. So you'll be able to divide off your 5 and get your z value of 6. Okay. Now that you have a z value, plug it in anywhere that has only 2 variables. So I can choose either the original here, or the original here, or the second middle one right there. So I'm going to start with the bottom one, and that tells us that x minus z, which is 6, is equal to negative 8. So if I add 6 to both sides, I'll be able to find the x value. So x is equal to negative 2. Now that I know 2 of my values, plug them in anywhere to find the third. Okay, so I'm just going to go ahead and use the second equation. I already knew the z value, so I'm going to use y equals 3 times the z value of 6. Y plus, one mistake there. 3 times the z value of 6 equals 22. That's y plus 18 equals 22. Subtract your 18. Okay, so y equals, and if I do 22 minus 18, that's going to give me 4. Okay, so now I have all 3 values. Answer in an ordered triple. So the ordered triple is going to be negative 2 for x, comma 4 for y, comma 6 for z. Okay. Hopefully that sounds good. The last example. Okay, in this one, we're going to be finding the equation of a parabola. And we already found some in parts A and B using the calculator and using regression. This is actually how I would need to do it by hand. And what we don't do it by hand very often. But the way to do it is to start with the standard form for a quadratic function, y equals a times x squared plus b times x plus c. And if you have 3 points on the parabola, you can plug each of those into this equation for x and for y. Just want to see what happens here. So the x value and the y value. So the y value for the first one is 9. So 9 equals, the x value is 1. So it would be a times 1 squared plus b times 1 plus c. Okay. The next ordered pair, the y value is 7. So 7 would equal a times 2 squared plus b times 2 plus c. And the third value, the third ordered pair, has a y value of 15. So you plug in the x value, that'd be a times 4 squared plus b times 4 plus c. I'm just going to rearrange these for a second. I'm going to rearrange them so that I have the ABC on the left-hand side, the number on the right-hand side. I'm also going to square this. So I'm going to start with a times 1 squared. That's just a. 1 squared is 1, so a times 1 is 1, plus b times 1 is just b, plus c, and I'm just going to write the equal sign on this side. It's just because it's how I usually have things written on the previous pages. My numbers are on the right-hand side. Sound good? So now next one, 2 squared, that's 4. So this one would be 4a, plus 2 times b, that's 2b, plus c, equals 7. Last one, 4 squared, that's 16. So 16a plus 4 times b, so 4b, plus c, and that equals our negative 15. Okay, this looks like a system that I could have seen on the previous page. Instead of being called x, y, and z, they're called a, b, and c, but it's very similar. So what I want to do is solve for a, b, and c. Now here, it's going to make the most sense for us to eliminate c because the coefficient on c is 1 each time. So I'm going to start with the first two equations, and how about we just multiply the top one by negative 1, keep the bottom one, or the middle one, the same. Then you have a positive 1 and a negative 1 to work with. Okay, so that's going to be negative a minus b minus c equals negative 9, the top equation. And then 4a plus 2b plus c equals 7. So that's going to give us negative plus 1 plus 4 is 3a, negative 1 plus 2 is 1b, no c's, equals negative 2. I'm going to do the same thing, but I'm going to use top and third this time. I like the top equation best because the coefficients are all 1. It's just easiest for me to work with. So I'm going to do negative 1 on that one again, and positive 1 on this one, so I can eliminate c once more. And eliminate the same variable 2 times. So negative a minus b minus c equals negative 9, and then we're going to have our positive 16a plus 4b plus c equals negative 15. Add them up. That would be 15a plus 3b equals negative 24. Okay, so I've got my c's eliminated in 2 equations. So now I'm going to take these 2 equations and eliminate a different variable. It doesn't really matter which one I choose. If you look at my a's, 3 and 15, both going to 15. Look at my b's. It looks a little nicer. They're both going to 3. So I'm going to keep this one as a 3 and then multiply this equation over here by negative 3 so that I have a negative 3 and a positive 3 to go along. Okay? So that gives me negative 9a minus 3b equals 6. And then I'm going to copy down the 15a plus 3b equals negative 24. Okay, so now I have to do negative 9 plus 15, that's 6a. The b's have eliminated. And then I have 6 plus negative 24, which is negative 18. Divide both sides by 6. That gives me an a value of negative 3. Now go into one of these 2 equations that only has 2 variables. I'm going to pick the smaller coefficients. So I'm going to go with 3 times a, which I know is negative 3 now, plus b equals negative 2. That's negative 9 plus b equals negative 2. If I add my 9 over, I'm going to solve for b. It looks like b is going to be 7. Okay. Now, I have a and I have b, so I need to find c. I can use any of the original 3 equations. I'll go for the top one, again, because the coefficients are nicest. So a, that's negative 3, plus b is 7, plus c is 9. So that would be 4 plus c is 9. So if I subtract the 4 from both sides, I'm going to get a c value of 5. Now, the last step to do here is my answer isn't going to be an ordered triple. In this case, remember that my answer, I'm going to push my page back down, my answer was going to be a polynomial where a, b, and c were the coefficients. It's going to be y equals a, x squared, plus b, x, plus c. So my answer is that these 3 ordered pairs are in the quadratic polynomial y equals a, so negative 3, x squared, plus b, plus 7, x, plus c. All those times that our calculator found us a model through regression, we could have chosen 3 points and wrote the equation by hand. This is the technique that we would have needed to use.